Hi lads, in this video I'm going to go through how to the 2013 higher level C2 question. It tells us the graphic on the right shows an uplighter in the form of a hyperbolic paraboloid surface. Figure C2 below shows the plan, elevation, end view of a similar uplighter. An isometric view is also shown. The surface of the hyperbolic paraboloid is generated by translating the parabola ABC in a horizontal position downwards along the parabola BD. B is the vertex of the parabola ABC, and D is the vertex of the parabola BD as shown. Part A, draw the given plan of the spot of the uplighter. Part B, project the given end view from the plan. And Part C, project the front elevation of the uplighter. Part D then involves the curves in elevation forming a portion of a double hyperbola whose vertices are V1 and V2 and whose focal points are located at F1 and F2 respectively. Determine the asymptotes of the double hyperbola in elevation. So to start this question, I'm going to draw a box for my plan to fit inside. So I'm just going to take a line across here. I'm going to take my central axis running through here. And the question I forgot to mention tells you the scale of 1s to 2, so all the measurements are going to be halved. So the total width of the base is 300, so it's going to be 150, which means 75 mm each side. And we're told that the plan goes back as far as a total of 180, which is going to be 90. And that's going to be a box for our plan. So we're going to draw the rectangle method to actually solve this question. So I'm going to divide the side up into 5 equal parts and divide the base up to 5 equal parts as well. So 1, 2, 3, 4 and 5 there. And our vertex is told as being at this point here, B, in our plan. So all of these side points are going to be connecting to our vertex at B. So just using sliding set squares, take our fifth one to the top and extend the rest of them out the rest of the way. And then I'll just draw my base as well here and divide half my base into a number of equal parts, so 5 as well. So let's divide into 5 there, and same idea again. I just use my set square and my t-square and just take these points in as well. So all of my side ones are going to connect to B, because B is the vertex of the parabola in plan. So you can see there, all of them are taken there. And then all of our vertical points are taken along here. And that gives me my second, third and finally my fourth point here. So that allows me to start drawing in my freehand curve of the parabola. And then when you're happy enough with it, go over and heavy your curve then as a result. Curves right around to the top one there. And then all you do is step your points across. You can divide the other side if you want, just to speed it up. Just take your widths across and just double them over because they're symmetrical on both sides. So that one will go to there. That one is going to go over across to there. And the final two will go to there and there. And now I can draw in my parabola nice and neatly in freehand all the way around to there, and draw my curve in heavy then as a result. That goes all the way around to there. I'm then told it's 60 mm, so I'm just going to take 30 each side here and here. I'm told that the parabola translates along the parabola BD, which is going to be drawn here in my end view. So what's basically happening is this parabola here is going to shrink down until it's the width of this here. So basically what I'm going to do is translate my points down to meet them. So what's happening is this width here, if I take that across there and that across there, just happens to hit off these 2 points on my curve. I divide it into 5 equal parts. What I'm going to be doing is cutting this parabola here and moving it up here instead. So what you need to do is take these points down, for example, on this side, and using my compass, I have this width here, or sorry, this height there, mark that down there, take this height here, so you can see that I'm taking that height there, and just make sure I got it right, and mark it down here. I do the exact same for the opposite side. So I'm just going to do it for 1/2. Draw that in heavy there. And what I'll do is exact same as before. I'll just step my widths across as they're symmetrical on both sides. So that width there moves over to there, and this width here moves across to here. And draw that in heavy then as a result as well. And now I have my parabola drawn in plan. After that, I'm going to draw my XY line up here, and I'm going to get ready to draw my end view. So I'm going to take my points across here that I'm given, and that's already taken across there, and I'm told the height of my end view is a total of 160, so I'm only going to go up 80. So the scale being 1 to 2. That can go heavy across to there, heavy down there, and heavy across to here. And with the parabola in end view, it tells the vertex is located at B, which is here. Or sorry, D, not B. It's located at D there. So I'm going to be dividing up this box here, use the rectangle method. All of my side divisions here will be connecting back to D there as my vertex at D in the end view. So same idea again. I'm dividing this into 5 equal parts. So stepping out 1, 2, 3, 4, and 5. Using sliding set squares again. Connect these ones along here. And then connect these 2 points all the way along here. Because it's only half a parabola, we can divide this whole baseline here into 5 equal parts. So 1, 2, 3, 4, and 5, and connect back to the end there, and I'm going to take these points up then as a result. So I take this up to here, this one up to here, the third one goes up to there, and the final one goes to there. And point B is out here, so B will connect all the way along there to D, and just go over in heavy there. And that completes my end view. Now moving on to my elevation where the double hyperbola occurs. So let's take all my heights up here. And I can see in the question that it's heavy from here to here, and heavy from here out to here. And I'll label these as V2, V1, F1, F2. and I can see I'm going to have a hyperbolic curve going around here and here. So there's two ways you can do it. One method is to use the rectangle method, where we actually divide up the sides similar to the parabola, and we are going to get our points and are going to plot all the way along here. The faster method would be to actually just translate it along. So you can see here the parabola is going to be translating all along here, so that's going to have an effect in the plan, giving us our widths to actually project our points up. So for example, if I take this one here, I want to find a point that is this height up. I want to find the width of it now. Because this parabola is translating all the way along from here, I could take this width for example. So I'm just using the points that are actually divided up as my heights for each one. So I'm going to have 1, 2, 3, 4 points along it. That point there lies along the parabolic curve along BD there. If I take that point and step it out from B, because remember it's going along that surface BD, so it's stepping out from B, I can take this width here, step that up, and that'll give me a point on my actual curve there. And what I'll do when I get the rest of them done, I'll just step them across the same way. Second one, I can take this width here, it's moving along the curve once again on BD. I can step that out here, take that across, take it up, and take my height across here, and the exact same with the third and fourth one. So it's just translating along it. So I take that down there, get a point here, take that across, up, and take this point across to meet it, and then finally my top one, taking this distance here, and it's moving along BD as well. That gives me that width there, and I can apply that width to here, and now I have my hyperbolic curve going along there. And all it's a matter of doing is stepping them across, as they're going to be symmetrical on both sides. So I take this width here, apply it over to here, and just repeat the process for the bottom 3 ones. And just plot the points along it again, draw along the curve in heavy afterwards, and that gives you your elevation then as a result. The last part, part D, tells us to draw the asymptotes. As a double hyperbola, our axis is going to be in the centre here. And just a recap from conics, I just get the book there to show you. Something we would have done a few weeks ago while I was still in school. If I go to the conic section, you'll see that let's go back to the hyperbola section. Sit here. We're given, in our question, if I move this out of the way, we're given F1 and V1, and our central axis occurs here. So what we have, it's almost like the top section here. This is the idea of being the uplighter. We have our curve going out each side there for hyperbola. If we take the distance from our centre to our focus and rotate it around to hit a vertical line going straight up from our vertex, we get a point on the asymptote, and we can draw our asymptote this side and then draw our asymptote on the other side. So a bit of a recap on conics on what we've learned before. So I'm going to take that central axis there, take F1, rotate it around, I already have V1 extended, and if I join this point here and this point here, that gives me one asymptote, and I just repeat the procedure on the opposite side. Update my vertex line, that'll give me my other asymptote. So just a little bit of conics actually put into the question there at the end in terms of your understanding of the asymptotes. And just label that there then. And that then completes the question. If anybody has any questions, please ask me on Teams, I can go through it with you. Hope that video helps.